Good morning and good afternoon, everybody. This is Elie. I am with the Clément, who helped me prepare this presentation for you. And the purpose of this presentation is to present to you one of the new technologies that Alwan has been developing for the last years, exactly the 5 last years, and which is Hydra Profiling. So Hydra Profiling as a technology is a new way of predicting color, a new way of using color prediction to build profiles. We will be seeing in this presentation what is Hydra Profiling and how we can use it in Alwan software. Okay, so let me start by reminding why do we need profiling. As you know, in a color managed workflow, color management is needed in order to adapt incoming color data to the output process. So in technical terms, we say that we need to adapt the reference printing conditions that has been used to define colors, brand colors or visual colors, with the actual printing conditions and capability of the output device. This is basically what color management is. Process control is about ensuring that a print device is printing to optimal expected printing conditions and making sure that these actual printing conditions are stable on the press by ensuring that the press is stable, calibrated and profiled, by ensuring that color management is using the color profile of a stable device. We have the guarantee that printed colors will be accurate. So this perspective on the workflow and this color management applied to a printing workflow has been the roadmap for Alwan software since 2011, as most of you know. And this universal printing workflow diagram that you are seeing is now becoming an ISO standard. It is in draft mode, DIS, which is nearly final stage. And this ISO standard 19302 actually is the materialization of this vision that color should be defined, managed, and controlled throughout the workflow. So when we speak about profiling, we can ask the question, when do I need profiling? As most of you know, especially those who work with offset presses, and specifically for CMYK offset presses, we have today what is called standard printing conditions. When we have an offset press printing with standard inks, having dot gain or tone reproduction curves that match ISO standard or G7 standard, if we have the printing densities or solid colors that match ISO standards, we expect this press to match the standard printing conditions, be it FOGRA, if we calibrate the press to TVI, or ID Alliance datasets, if we calibrate the press to G7. So this is actually a very specific case, not to say the only scenario, where profiling may not be necessary. And in this case, profiling can be useful for some brand colors or specific colors, tints, backgrounds that are printed with device color builds and needs to be matched within a very low delta E. Other than that, having a calibrated press using standard inks, matching solid color aims and standard tone reproduction curves can do a good job in reproducing standard printing condition and matching FOGRA, ID Alliance, ISO 15639 data sets, and possibly proofs. However, this is an exception. The general case, and especially when we are working with other processes, including digital, flexo, gravel, and even offset when non-standard inks or substrates or sequence rotations are used. In these cases, profiling the output process is necessary. So profiling output device is something that you do, of course, that we all do and have done for many years. Now, the question is, why do we need Hydra Profiling? And what would be the added value of having a new profiling technology when there are few out there who work very well? Hydra Profiling has been built in order to make the profiling operation easier and with lower cost, if any. If we take conventional profiling, which is the way you and I have been doing profiling for years, not to say decades. To profile a press, we need 2 to 3 print sessions, right? The first print is with linear curves, so we can generate tone reproduction curves that corrects for the press natural tone reproduction curves in order to match either ISO TVI or G7. Then we will print an IT8 applying these adjustment curves in order to measure the print and build the press profiles. And for those of us who have time and the ability to do so, we will have a third print to check that the proof and the press match, that the profile is accurate, that it is smooth, and that everything went well in the calibration and profiling operations. So 3 dedicated print sessions on a press. And as those of you who underwent this operation, you know how long it is. It takes practically a shift to have these 3 print sessions done. Special attention and special care is most of the time taken in printing the IT8s that will be used for profiling. And this attention and these printing conditions may not be actually the normal printing condition at the printing plant. So by having a specific printing conditions generating a specific ICC profile, even though it may be a very nice optimal ICC profile, well, this profile does not necessarily represent the press behavior and the press color production capability in daily production. So this is a technical constraint that we are all aware with. Experiences have shown that profiling sessions, printing conditions, do not always match production printing conditions. Now, this is a technical constraint that can be overcome if the profiling printing conditions are standardized in the printing plant. However, the other big constraint in conventional profiling is that this profiling using IT8s, which require specific printing sessions, they cost a lot of money. The press is not in production, so we're not producing jobs. Resources are not in productions. They are making sure that everything goes well in file, CTP, and on the press. And the cost of this operation that has been calculated by one of our beta sites where we compared conventional and Hydra profiling recently, came up with a 4,000 euro figure, which was the cost of profiling their press with one paper. So a profiling operation which is long, which is tedious, and which is costly, with a result that is not always the best results that can be obtained. Now, with Hydra profiling, we do not need to print IT8s. We print a control strip. For an analog process, we only need 40 patches. And by printing this control strip, or these 40 patches included in a color bar, during production, we are able to modelize the ink and paper, and more generally, the colorant and substrate interaction with light, and to build the press profile without any dedicated print session. This color bar, these control strips are measured in production. So the data obtained is a data which represent production conditions. The machine is producing jobs. We have virtually no resources allocated to this work since we are in a production environment. So the cost of profiling the press with Hydra technology is nearly zero. And here you can understand the price of the profiling option, and this would be, I would say, the only information, commercial information in this presentation, which explains to you the price of Hydra Profiling. The 4,000 euros is the equivalent of the cost of profiling one press, one paper, which here with Hydra Profiling allows a printer to profile all his presses with all his papers and substrate. So now let us see in details what is Hydra Profiling and how does it work. An ICC profile is basically n-dimensional table, n being the number of colorants of the profile device, right? So for a CMYK device, we have 4-dimension tables. Each dimension requires steps, grid points, we call them, which means that if I want to sample the color space in 10% increment, 0, 10, 20, 30, 40, I need 11 points, 0 plus 10 values, which means that in 4 dimensions, my profile needs 14,641 points. This is a small profile. If I want a large profile to get a higher color accuracy with something like 3% increment, I need 33 points per dimension. So for my CMYK profile with 33 grid points per table, I need more than 1 million colors. For a 7-color device, it is between 19 million and 42 billion colors to sample the color space. So how can I get these tens of thousands and millions colors? I cannot print these colors. So this is where the test charts come into play. This is why you print IT8s, which contain approximately 2,000 patches. And these IT8s allows you to sample the color space in some critical points that has been found to be representative of what is needed to have a good color model of a press. And then a mathematical operation called interpolation is used to calculate your 10,000, 1 million colors that are not printed. So this interpolation, which is a prediction of what would have been a CMYK patch color if had it printed, this mathematical interpolation have an accuracy level. And this accuracy is higher if the number of samples is higher. So you can see here the limitation of mathematical interpolation, where the highest accuracy possible is with the highest printing samples possible, so with the largest test chart possible. This is an illustration of a color, C, for which we need to calculate the color value, the lab color value, whereas in the test form, in the test chart, in the IT8, I have samples for P1, P2, P3, P4. This means that my 4 patches, printed patches, P1, P2, P3, P4, will be used to calculate with an interpolation algorithm a prediction of what C color would have been if it had been printed. This is what is called an interpolation, right? So the closer P1, P2, P3, P4 are to C, the more accurate is the prediction. So conventional profiling is something that we have used for the last decades. Interpolation is the technology that is used by all the profiling software that you know of, maybe with one exception of software which partially use spectral prediction. However, Hydra Profiling is the new Alwan technology, patented because this is the only technology today which is 100% based on spectral prediction. So what is spectral prediction about? The spectral prediction is not about calculating a color from adjacent printed colors using mathematical interpolation. Spectral prediction is about modelization of the interaction between light, your instrument light, the colorant, your ink, the substrate, your paper, and by understanding how this interaction works, so by modelizing the physical characteristic of this interaction, to be able to calculate, to predict the non-printed patches. So this is a completely new and completely different science than conventional profiling, because it is not based on calculating points using the nearby printed patches from the IT8. It is based on understanding the physical characteristic of your colorant and substrate, and from this physical modelization, predict what would this colorant look like in color terms when it overprints another colorant that has been spectrally measured on a specific substrate. So in this case, the accuracy of the prediction does not depend on the number of points. It depends on your model accuracy. And this is why with Hydra profiling, you don't need so many points, because you need to understand the ink and paper relationship. You are not sampling the color space. This is a very simple example where you can see printed patches of yellow and blue. This is two colors from Alwan 40 patches control strip. And when we want to calculate the green, there is no interpolation as we saw with the mathematical interpolation. Here we are multiplying the spectral curve with a function, specific function. This function can be process dependent in order to give a very accurate prediction of what would the green patch color be had it been printed. So Hydra profiling is about spectral prediction, is about managing spectral information by using the physical characteristic of your ink and paper, more generally colorant and substrate, rather than by finding the closest color in an interpolation operation. So now let us see how Hydra profiling works with the new Alwan software. As you know, Alwan ColorHub version 6 and Alwan PrintStandardizer version 6 use Hydra profiling. However, each implementation of Hydra profiling has been adapted to each software because the needs and the workflow in the press room are different from the needs and the workflow in the pre-press room, right? So we have in our workflow the color management part, which ColorHub manages. In the press room, we have PrintStandardizer part, and combined together, these two solutions today offer a complete closed loop, which allows you to calibrate, to profile a process, a printing process, digital or conventional, and to apply the resulting curves and the resulting profile automatically and instantaneously in your color management server. And this is unique because, as you know, a lot of our competitors do a very good job in color management. Some others do a very good job in calibration of the presses. Some others do a very good job in profiling printing processes. But we believe today that Alwan is the only company offering these three technologies, and not only offering these technology, offering the state-of-the-art technology in these solutions. So with the Alwan solutions, you are able to implement a completely closed loop for conventional and digital printing processes, which enables your customers to have their print device calibrated and profiled continuously in real time, and the up-to-date curves and the up-to-date profiles applied in Alwan ColorHub on the color management side. And to give you an example, we did this example recently with Konica Minolta. I was able to calibrate and to profile a Konica Minolta printer using Konica Minolta software, which is called Color Central. And the operation took me, with the operator who was there, approximately 2 hours. When we did the same operation with Konica Minolta stuff in our offices using PrintStandardizer and ColorHub, calibration and profiling took 2 minutes. So you can understand here that besides the practical side of having automated state-of-the-art engines that calibrate, profile, and color manage your workflow, the financial return of investment is huge because you don't have to allocate resources in order to have your output colors matching your proofs or matching your files. So let us see how this can be done with Alwan software, starting with PrintStandardizer. And I'm starting with PrintStandardizer here for the simple reason that for me today, and I would like to share this excitement with you, without PrintStandardizer, I cannot imagine that we can have a controlled press room with predictable output quality. As you know, digital as well as conventional print devices are not stable. Ambient conditions can change. Ink toner can change. Substrate, even in the same category, even in the same time, even from the same type, even from the same series, can change because 2 rolls do not come from the same mill. So we have fluctuation of the process. We need to stabilize the process to make color predictable. And this is why PrintStandardizer has been built, right? So PrintStandardizer, the press calibration engine that you are familiar with, is still there. Now we have added to it this new capability that we call Hydra Profiling. And when you check Hydra Profiling, you enable the spectral prediction and the spectral profiling using PrintStandardizer. How does it work? When I check Hydra Profiling, I have 4 ways of defining my solid colors on the press. The first one is to use a profile, which means loading a profile that can give me the aims, choosing a data set, loading a data set that can give me the color aims for my primaries, using the Alwan color library, which can be composed of CLAB colors, but also of spectral colors, including CXF and CXF-X4 colors. I can build a process from scratch by using just the inks. And I can work with a printer, a digital printer, for example, where I don't have a standard profile or data set as a target for this printer. So I just use the printer in its linearized and calibrated state using the printer DFE or the printer driver, and then ask PrintStandardizer to accept the print solid aims as being my target. So 4 options. And whatever option I take, I have my process colors. I have my process color sequence, which is important, as you know. We take color sequence into account. And if the target is spectral, we are calculating here the densities, the target densities for each ink. So my color aims here are defined. Now that my color aims are defined, I need to tell the software what are my dot gain, TVI, or tone reproduction curve, right? So here I have also 4 options. I can use the TVI of the profile. I can have custom TVI. I can have gray balance, G7 curves. And I can use the linearized, calibrated print device curve. So I have control on the solid colors. I have control on the tone reproduction curves. And in each case, an option that allows me to adapt to the device, to the workflow, to the ability of the print device driver to define color aims and tone reproduction curves or not, in order then to calibrate and profile the device. So my job color ticket that you are all familiar with defines my aims and tolerances. And now I am going to show you how we can set the profiling options, right? So in terms of device calibration, now we say device adjustment because we can have calibration and or profiling, right? So regarding the filtering part, you are familiar with the filtering part, and this filtering part has been reinforced for profiling, which means that for calibration, we make sure that the different data we get from a control strip, right, is relevant when compared with the target solid colors. So anything beyond, in this case, delta E of 6 gets discarded, and all solid colors that are within delta E of 6 of my target aims are retained and used with the nearby tints to calculate the zone reproduction. So filtering still works, but for profiling, this is not enough. For profiling, we have added a layer of filtering, which allows you to test if the measured colors that are destined for profiling come from the same substrates or different substrates. When it's densitometry and the color of the substrate is zeroed, right? You just, use density and calculate with Murray-Davis and you get a TVI. So in a way, you are not dependent on paper color when you are working with density and when you are calculating TRC. But when you are calculating a profile, and since color depends on the paper and the substrate, right? So paper substrate and substrate color is very important. And we have introduced here a filtering which allows us to make sure that when we build the profile, the colors that are used to build these profiles correspond to the same, not only paper categories, but also paper color. Calibration is still the same. You have the ability to generate tone reproduction curve adjustment for all popular ribs, with the last version even for new founder ribs. We have front and back for Zycon ribs. I think that we have the full list of available ribs and BFI out there. Anyway, all your requests and all the ribs that you have submitted to us have been supported in version 6. In the profiling part here, we can see that we can build profiles online, which is of course what we would recommend in production, but you can also build profiles offline by importing a data set and creating a profile like you do with any other profile builder. However, I would like to attract your attention to the fact that Hydra Profiling is based on spectral prediction, and spectral prediction means spectral data. If you want to have the best result with Hydra Profiling, you need to use spectral data, right? So when you import data from an instrument or from a previous measurement session, please make sure that this is spectral in order to maximize the quality of the prediction and of the profile which is built out of this prediction. So online mode would be the mode that we would recommend to you. And this profiling mode allows PrintStandardizer to take data from production. And when we have data, this data is filtered, as we said. It is categorized with paper color and then normalized before being averaged and smoothed if required. And the profile built with the grid resolution that you require, as we said, depending on the size of the profile that you want. You can see here that a small profile weighs 1 megabyte, but I can give you an example of a 7-color, 33 grid point table profile, which is many gigabytes. So you don't want to spend hours, even days, building a profile. So Alwan, depending on your printing process, will suggest the optimal size table for the A to B, device to PCS, or V2A, PCS to device tables. The separation is the same as the separation that you have in ColorHub with all the GCR levels, and in hi-fi mode with priority to OGV or to CMYK inks. So priority to CMYK or to non-CMYK inks, depending on what you want to achieve. Before leaving this window, let me show you here this data qualification part, which reminds us of the filtering I introduced to you. Whereas before using color data coming from a press, even if it was for the same category, we are making sure that the color data is homogeneous because the substrates and the printing conditions are homogeneous. In the same queue, coated paper, if I have a bluish paper and a yellowish paper, of course, you understand that it is difficult, not to say dangerous, to just average the two data, right? If I have the same paper color, but I have different printing conditions, solids, TVI, you understand that I can average, but I can get a bad average. Always remember that the average of bad data is a bad average, right? And this filtering and this specific data qualification for profiling that we have built for you here is to actually do what you usually do when you choose characterization data, when you qualify characterization data to build a profile. Well, here we have the technology that probably does what you do, which is making sure that the data that we use to create a profile makes sense, is homogeneous, and is good to build a good average and then used to build a good profile. So PrintStandardizer allows us today not only to calibrate a press, but to profile a press in real time. ColorHub is in pre-press. The needs in pre-press are different. And this is why the implementation of Hydra Profiling in ColorHub has been done differently than PrintStandardizer. Here, it's not a question of receiving measurements, which is the case for PrintStandardizer. Here, it is about building a new profile or editing an existing profile. Let me show you how we can build a new Hydra profile. I am in the output separation window. I click on the plus button, and I have this window showing me the gamut, two-dimensional gamut, numbers for my solids, volume for the number of colors that can be printed on this device, and this plus sign which allows me to import a data set. Let me import a data set, maybe more. Let us import more data sets, 3 data sets. Why do I import 3 data sets? Because this is what we usually do. When we profile a press, sometimes we take a sample from one printing session, and then we take a sample from another printing session, and then we take samples from other printing sessions, and then we average these samples to create a profile that represents average printing conditions, right? So same press, same substrate, 3 different times, 3 IT8s, and we average, right? So if you have today a database of spectrally measured IT8s or other ECI chart or other TC 2.9, 3.5, whatever test chart you have, we don't need thousands of colors, right? Any test chart that you have, you can import here. You can choose for each test chart which channels you want to use. Let me give you an example. I'm sure that you had this case where you have this printing sessions, and when you measure the printed IT8 later, you find out that it was nearly perfect, but not perfect. CMY ramps were perfect, TVI spot on line, gray balance spot on line. However, for some reason, the press miter, opened a lot with black, and the black density is very high, and so the black TVI is very high. However, everything else is perfect, right? What we usually do is say, it's a pity. It could have been a great data set for a great profile. And we go and do another print session. This is what we used to do. In this case, I can keep this data set, just unchecked by double-clicking on the black and saying, from this data set, I want CMY. However, from the other printing sessions, where for some reason the cyan got dirty or the magenta got washed out for some reason, whatever reason, I don't want these two channels. I can check the channels I want. So here I have checked yellow and black. And this one is fair. So I'm going to use a perfect CMY print, a perfect yellow-black print, and a good CMYK measurement file, and ask ColorHub to average them. If I want, we can even smooth them. We do intelligent smoothing and build the profile. And here we can see that we can compare the resultant profile with a reference, any reference. Here we took one, which is LWC paper, this is the FOGRA profile. And so we compare the profile that we have built, volume, with the profile, the reference profile. So these numbers, just for your information, since most of you are color and print experts, this is relative numbers. We don't have yet a standard formula to calculate gamut volumes. We are working on it inside the ISO TC130. This is one method which tells you, in simple words, how many delta E cubes you have in the gamut, right? So the difference between what you see here and probably ColorThink or other software is how we calculate the number of cubes, but more or less you will get similar results, at least relatively, you will have similar results. So this was the CMYK, right? Profile that I have built from the 3 data set, and I have it here ready for my color separation. Let me take you now to the hi-fi extended color gamut world, where the problem of profiling is even more severe. What is the availability of a flexopress? What's the cost of profiling a flexopress compared to offset? 10 times more. What is the stability of a flexopress compared to an offset press? 10 times less. So very difficult. So whenever you have a time slot on a press, it's precious time. So let's use it to have a good data set and use this data set to build a profile now, but also in the future. Let me explain to you what I mean by this. This is a press that has been profiled for 6 color, right? So I have here a 6 color profile. However, this is a spectral profile. This is made by Alwan, so we have the spectral data in the profile. And there are some changes in the printing condition of the next job. So I'm not printing CMYK OV anymore. I need here a job with full expanded color gamut with the green. So I will press on the edit button here, and when I press on the edit button here, I will see my in color sequence, I will see my profile primary channels, and I will see my profile volume compared to a CMYK volume, right? 455, I'm not happy, I want more. I want to print Pantones on this press. So I want to add, and I'm going to add a spectral data. Look at this spectral data. This is a 7 color print that have been done on this press some time ago, but we have the spectral data, right? And we have the green ink that we need for the press. So my press today is represented by the 6 color data, and I need to add green. So I have 2 options. Either I can print 4 times test charts to have the conventional way 7 color profile, or I can print the Hydra control strip for 7 color, but it's in both cases, I have to print something. And the option here that ColorHub offers you is to take characterization data, a data set, which contains the green ramps that you need for your press. You check your green here, and you will see immediately that it is in your color sequence. You can adjust the ink sequence rotation here, and you can see immediately the result here, where your color gamut is not 455,000 colors, it's 567,000 colors. So we have the ability to, for an existing data set, spectral data set, to add, which is we just did, but also to remove. If I want to use this press with CMYK and orange, because I'm printing Orangina box, I have no blue in it. It's orange and shades of reds and yellows and black text. So I have the ability to uncheck violet here and automatically have my 5-color process profile for this press. So very powerful way to build profiles from existing data sets and for editing profiles without having to undergo additional printing session. When we speak about profiling and about prediction, I would like to attract your attention to something very important that you will not read, that you will hear from me today and will probably read from Alwan after the holidays. Building profiles from data sets is not an issue. You have even freeware, open source profiles who do build ICC profiles from data sets. It's documented, public information. What's the difference between different profiling software? It is the color accuracy of the profile. How accurate is the profile in predicting the colors of this press? So we can use it for proofing, but we can use it also for color separation, and we can use it for repurposing, right? So accuracy is key. And in some cases, you can hear about new profiling technologies, and I don't want to name anybody because we are all learning and we are all improving. No technology is perfect today, but we believe that our technology is the best for this reason, because we publish the numbers of how accurate is our profile compared to an IT8 based profile. Because building a profile out of ramps, which is today the trend, everybody can do it. And we can do it, but you don't have it in this version of the software for a specific reason that I will explain to you. However, what is the accuracy of a profile which is built with 4 ramps of CMYK? This is the question that we should ask ourselves when technical paper or when a vendor is trying to demonstrate that 4 ramps, if we wanted to be pedantic, we will say 4 CXFX4 files is enough to create an ICC profile. Yes, but how accurate is this profile? Here you have the accuracy of Alwan profile, demonstrated accuracy made by our color scientists, 0 bias. We are as good, as accurate in terms of device to PCS, which is in terms of color prediction, as an IT8, with all the advantages we have talked about: no print runs, no overhead, no cost, just by measuring in production. These numbers are in the Hydra profile brochure that you have available in our partner sections, of course. Now, in terms of B2A, which is the separation table, as you know, this is a completely different story. B2A is about PCS to device, is about color separation, is about matching input color on output device. So this is very important, with 2 ways of looking at this color transformation. One way is how good do I match colors, and the other way is how good is my image. So one is about color accuracy, which we call relative colorimetric, rendering intent, and the other way is about having nice pictures, nice images, which is the perceptual rendering intent. And just to finish with this performance part, I would like to show you 2 comparisons with what we consider to be the industry standard profiler, I1 profiler on the left, and Hydra profiler on the right. And those of you who are familiar with our software, Color Pursuit, you can see the widget on the right with the white, delta E0, green, delta E of 4. Light green is probably delta E of 2, right? Yellow, brown is higher than delta E of 4. We have no yellow or brown in this picture. Everything is between white and light green. The average delta E is 0.5 between our profiles and I1 profiler using the same data set, okay? We're not into the entire process of prediction and building profile. This is about building the profile. So you can see here that even though this is version 1 of Alwan profiler or Alwan Hydra profiler, it is as good as the best profiling software out there. And when it comes to perceptual separation, as you know, there is no defined protocols, algorithms for the gamut mapping of the perceptual separation, which is supposed to give us pleasant images, you know, full contrast, colorful, nice to see images, right? So no two perceptual separations are identical. You can check any two pieces of software in the world, even the same software with two different versions, you can get different results, right? So this is the best I can do kind of color separation, right? And here you can see that the results between Alwan Profiler on the left and Alwan Hydra Profiling on the right is nearly identical, which means that we have been able to match Alwan Profiler ability to do very nice color separations. We can see here lots of details, of course, in the, you know, you can see the blacks, you can see the hair. I will not get into the technicalities. This is subjective view. The images here are splendid, and those who saw differences that you can see in the cheek say Alwan is better. But I don't want to go into this. I just want to attract your attention that even though this is the first version of Hydra Profiling and more is yet to come soon, we can say very proudly and modestly that we match the best profiling engines out there by using what differentiates Alwan from all other packages is that we have made profiling easy and virtually with no cost.